Yeah, and as you said, I mentioned this to Gaitan as well. He kind of set me up perfectly for what I'm about to speak to you all. And I'll try and keep this brief because I'm the only one between you and the trip to the pub, or for anybody with young kids, bedtime, I suppose. So just to set the scene for my conversation, this graph, I'm sure we've all seen a version of this graph, open source exploding, and the usage of open source exploding is not news to any of us here. And this is essentially the open source downloads across all major ecosystems, including the container ecosystem, Docker ecosystem. And this is fantastic for me, someone like me who always worked in open source organizations. We've seen a lot of innovation being brought about due to this. But we get to build our software on the shoulders of giants, essentially. And what it also means is a lot of our applications, therefore, are built on code that we didn't write, which isn't necessarily a bad thing, but also there are some risks associated with it. The second chart, I'm sure all of us have seen some version of this as well, essentially talks about the amount of CVs that have been climbing at an astonishing rate. What we can see there clearly is that the rate of CVs being published is at a much higher rate than the rate at which open source downloads are carried out across major ecosystems. Now, this is not really like I don't mean to scare folks with this slide, but it's also important because open source is important, especially in the age of AI and agentic applications. And speaking of AI and agentic applications, what we've seen is that's not necessarily reducing the risk that we have to play with, right? It's when we give these agents autonomy and when we rely on non-deterministic systems, we don't really have full control over what's going to end up in our supply chains, what sort of malware is going to get pulled down by these agents. And this is a problem that we've thought about a lot at Docker. It's something that while we had a sort of front row seat to the explosion of open source, we've also kind of looked at this issue, and all of us here are here to sort of try and address this problem. What we realized at Docker was we've kind of seen this problem with containers as well. We've solved some of these problems about a decade and a half ago, and some of these are things like isolation, which containers do pretty well in limiting the blast radius of an attack. Things like minimizing what's inside a container. I think Gaitan talked about this as well, including only what's absolutely necessary so that you reduce the attack surface. And I loved that he referred to multi-stage builds. You kind of reduce the size of that image to reduce the attack surface. And then also things like provenance, where these images come from, where what sort of information we get out of the images or get alongside the images is something that we believe is very important. And just kind of highlighting this as we talk about open source and AI and agentic applications, what we've seen in our front row seat is this is taking off in the age of AI, right? We feel a huge amount of stewardship towards not just securing containers, but also AI. As Gaitan mentioned, Docker Hub has like 11 petabytes of data as the world's largest registry. And we've seen this, again, a sort of second growth spurt almost for open source, with LLMs, MCP servers being published as open source containers, content, and then containerized. And just to pivot from this sort of current standpoint, what in preparation for this, what I did was look at a bunch of publications over the last couple of years, and something that really stuck out for me was this publication by Black Duck that talked about how 89% of code bases that they evaluated or scanned had open source components that were more than 4 years out of date. That's stuff that's not been touched for 4 years, which is a bit nuts if you think about it. A good illustration of this is, I'm sure Shai Hulud would make some of us kind of think of sleepless nights from September to November last year. And this kind of harks back to what I talked about earlier. We build our software on top of stuff that other people have written, and we don't know like what's inside these. And a lot of these packages that I'll show this in a second in a small, not necessarily demo, but in a small exercise, you'll see that there are these packages that we don't really need to be pushing into our applications. What I'm trying to get to with all of this is, we are of the opinion at Docker that you could be doing SCA and SASD and all of these types of scanning, but application security kind of starts with your base image and your dependencies. If you're not kind of securing your base image, you're building a bridge on top of a cracked foundation. And so what we've identified is what we call, our lead security researcher is calling the 5 pillars of container security. And I'll talk about these in a second. And again, thanks very much, Gaitan, for kind of talking about some of these, because you actually referenced some of these things in your talk as well. Obviously, the first one he mentioned was minimizing the attack surface. So only including what's required inside your Docker file, and therefore your Docker image being quite small. So reducing that attack surface and stripping out any unnecessary libraries, developer tools, things like that out of that Docker file is critical. Next, what we also see is making sure you have all of the information you require by way of 100% complete, not minimum, with no minimum depth, by way of SBOMs, right? So CISA has kind of defined a great standard around this that we highly recommend. The next one is also to ensure that there is verifiable provenance for those images, making sure there are attestations provided, such as SBOMs, that talk about who built the images, how they built them, what they used to build them, and making sure those are non-falsifiable. And also having standardized mechanisms to talk about the vulnerabilities that you're getting. If you have all of these SBOM information and the CVs and stuff, that's great. But if you don't sort of properly contextualize that, that's only going to add to the CV fatigue that developers all over are kind of encountering. And we are big fans of the VEC standard, for example. That sort of thing can provide developers with the right context as to which vulnerabilities are really relevant to them. And lastly, all of these things to be sort of non-falsifiable, right, and tamper-proof, so that anybody is able to kind of look at all of these attestations and say with a high level of trust, a high degree of trust, that these are legit, right? So these are the 5 pillars that we've kind of identified for container security, and these are all standing on what we feel is a base or a foundation of 100% transparency in all of these processes and artifacts that one delivers when they build container images. And what we've seen, and I work with a lot of our customers that kind of take this approach, what we've seen is a huge mind shift change in their organizations from a sort of security, from a trust standpoint, just developers saying, trust me, bro, to a verification process, right? Where there is sort of some legit tamper-proof proof, I suppose, to say, how these images were built, where they came from, and so on. And this is not just Docker saying this. We've over the years had lots of publications come out. NCSC published something 2 years ago about like using containerization, and here there's a guide called Building Container Images that talk about pretty much the same stuff that Gaitan referenced, that I'm talking about. And OWASP's own sort of top 10 OSS risks guide talks about some of these mechanisms as remediations as well. Um, and so what we've done at Docker is we've published this thing called Docker hardened images that people can use on top of what we have by way of Docker verified publish and official images. So I'll give you a quick overview of what these look like. Just gonna change my share screen. Yeah, that's good. Okay, so what I'll do is I'll kind of like use this tool that we call Docker Scout. It's our SCA tool that we use internally, and I'll look at a node image, one of the sort of latest node images. I'm just gonna. Right, and what Scout's gonna do is kind of give me the vulnerability information for this image, and you can see here that it's got like 179 vulnerabilities across 43 packages, and I'm gonna do a quick. Actually, I think I have this. Yeah, so I'm gonna look for those sort of npm packages from Shahilud, and then this is one of the latest npm packages. And if you sort of go up here, there's like debug, chalk. All of these are the npm packages that were exposed to Shahilud or infected by Shahilud like last year. Let's take a look at the hardened image that we have for this same one. And hopefully this works. Um, if not, I've run this command before. Let's see. Okay, there we go. So this came out with no vulnerabilities at this point, right? In fact, when I tried this out earlier today, it looked like there was one uncategorized vulnerability, but it looks probably we delivered a vex statement because of that. What I want to do next is I want to compare these two. I'm gonna just jump into Claude because it's gonna summarize uh, these two images and give us a good summary of the differences. Oh, yep. Good shot. Thanks very much. Thank you. So let's think this should come out pretty quickly. It's probably going to rack up a big bill for me, but we'll see. I think I've been expensive. Um, oh, classic. My bad. That's yeah. cross all of your fingers and toes for me. Let's see. I think it's now you see the tokens racking up, and then at some point it's going to it's gonna spit out a result that's far too heavy. Right. So this is kind of what I wanted to show you guys. This is sort of a side-by-side comparison of the hardened image and the sort of Docker official image, which is what I previously checked. The vulnerability count, as you can see, obviously has been cleared, but more importantly, the size has been reduced by about nearly 90% here. 397 MB to 39 MB for the hardened image. We've removed, I think, a ton of packages out of that, and then improved several different policies, right? So changed that hardened image to a default non-root user. Again, something, thanks Gaetan for mentioning this, using that principle of least privilege within that image. So this is a mechanism that we highly recommend folks use. It's a lot of vendors out there doing hardened images. Highly recommend you check those out, because it's definitely going to add a lot of value to your developer workflows and your software supply chain security. So let me switch over to my presentation again and talk about how these sort of principles can now be applied to agentic security, right? AI agent security. Before we sort of jump into that, let's take a quick look at a very, very abstract architecture for what an agentic application looks like. So you've got sort of the LLM sitting somewhere, and then you've also got the single application with the agentic application connected to various MCPs that connect you to the various tools that you want to call. And then you've also got the sort of user interface, right? Now, the problems with this kind of architecture is, firstly, there's very weak isolation, right? There's an agent and an MCP that is connected and runs on the host directly. It's got access to all of your resources, which is kind of scary when you think about it. And then secondly, you've got these MCP servers connected to all kinds of tools, GitHub, that are able to essentially carry out all kinds of actions on your behalf, and things like run arbitrary code on your repos. And then if we look at the interface layer, there are lots of vulnerabilities or exposures by way of things like prompt injection. There's no filtration of what's coming in and out of this. And then lastly, this is kind of my favorite quote from one of our security teams: LLMs can't keep a secret, right? It's like, if something gets leaked, it's probably going to be out there, and somebody could prompt it and extract what you've taught the LLM. And we've seen sort of the results of this already. These are some of the articles that I came across when I was kind of researching this. Lots of businesses have been stung pretty badly by this. And in our approach to fixing this and applying the containerization principles, what we also saw was there's a lot of industry publications that had arrived at pretty much the same conclusion, and OWASP has published a couple of guides around this, and we were glad to see we are in line with those. So let's look at how we apply those container security principles in the era of the AI agent. So if we look at the architecture, the first one we obviously recommend is isolation, right? As we did with microservices, you can isolate each of these individual components separately, and at the end I'll talk about like what we've done at Docker to help with this. The next one is have some kind of secure and centralized way to orchestrate MCPs and have the MCPs not necessarily do it themselves, but have some mechanism to allow the MCPs to store credentials securely, to store authentication details securely. So something like what we've called an MCP gateway in this case, so that it's not able to do exactly whatever it wants when it comes to tool calling. And then also have some kind of layer around the agentic application that does monitoring the input and output. And if there are secrets, for example, sanitizes that output. And then, yeah, what we've done at Docker, and by the way, all of these capabilities are open source, so anybody can use this. So the first thing we kind of released, I think middle of last year, is something we call Docker Model Runner. That's available on Windows and Mac platforms, where you can easily manage or run and build LLMs, and you can sort of build these and store these as gguf files or other OCI artifacts, and store them on any container registry. And then we also built an open source, something we call the Docker MCP Gateway, which we've wrapped into something called MCP Toolkit that anybody can use again. And the MCP Toolkit allows you to centrally manage the authentication, as well as have a way to kind of orchestrate the various clients and the tools that you might want to use alongside MCPs. And this is closely coupled with the MCP catalog, which is a curated list that we maintain on Docker Hub of MCP servers that have been containerized. And lastly, this is kind of my favorite capability that we recently announced, which is Docker Sandbox, where you can run the agent within a container, give it access to whatever it needs access to, but there is file system isolation. So if suddenly the agent decides to nuke your whole file system, it really can't. Which I think in the case of, in one of the examples I showed earlier, has actually happened several times. If you go on Reddit, you can see like lots of horror stories where Claude or Gemini's nuked someone's entire file system, right? So yeah, just to wrap things up, again, kind of referring back to my previous slide, this whole story around agentic applications very much reminds us of where microservices were about a decade and a half ago. There was messy packaging and distribution around all of this. There's very big security, fragmented discovery, and also lots of governance and compliance gaps. So there are lots of vendors out there building all of these, but I think the message I want to share with you is we've kind of solved these problems before for different things, but if we can tactically apply those lessons learned as I talked about today, I'm sure we can secure our agentic workloads as well. So I invite you to check those mechanisms out. Thanks.